Welcome everyone. My name is Basudev Mojumdar. I am the TA of the course of analog circuit. Last time we have seen that we have solved rather some problems which are related to the unity gain magnitude, where the gain of the any transfer function or the circuit given is becoming unity. And also we have seen that if any problem is given in op amp, how to simplify that problems circuit, and how ultimately we can achieve the magnitude, and from there how we are calculating the pole frequencies, the zero frequencies, and also how we have drawn the board plot from that. And we have also learned that if any circuit given, from there the concepts of drawing the board plots will remain same, just we have to find out the transfer function or the output Laplacian divided by the input Laplacian, and from that we have to find out the necessary informations to draw the board plots. Today we will see in our second part some of the problems which are related to the gain margin and phase margin, and also while discussing the gain margin and phase margin, the concept of the unity gain frequency will frequently come, that we have discussed in our previous tutorial. Let us start with the problem. Consider the inverting amplifier in the figure with R1 equal to 99 kilo ohm and R2 equal to 1 kilo ohm. The op amp shown below has infinite input impedance zero output impedance and has the following transfer function. So, this is page number 1, and this is in continuation of our previous tutorials. So, it is the problem number 4 and this is today's problem number 1. The circuit is minus the inverting non-inverting terminal is grounded. This is R2, this is R1. The value given is 99 kilo ohm and this value is 1 kilo ohm, and V in is applied here. And we have told that the GS, that is the open loop gain of the op amp given, is 10 to the power 7 divided by S plus 1 into 10 to the power minus 3 S plus 1. Now, what are the things we have to find out? So, this is the circuit and the basic problem description. Now, from here what we have to calculate? Let us see. The first we have to calculate is derive an expression for the overall loop gain. Part B is the same way, find the unity gain frequency. Actually, this part we have covered in our previous tutorials, but the while solving our next problems we require this part to be calculated. That is why we again have inserted this one to calculate the unity gain frequency. Now, at the above calculated unity gain frequency, evaluate the phase margin. Now, the problem has a little bit trickier extension. So, they are telling you may have got a low phase margin in the above question due to the fact that the op amp GS was designed very badly. We are assuming. So, we will see what the phase margin it is coming, and we are expecting that the phase margin is what we are getting is not up to the mark or up to desirable. So, we want to improve the phase margin. So, that low phase margin problem has been improved by some techniques that we are explaining in this trickier extension. Suppose we wanted to improve the phase margin, and we do not have the access to the internal circuit. So, this part is important because any op amp generally we are not allowed to change in our internal circuit. What we have to do? We have to adjust our the external resistor connections, and from that we have to achieve what it has been asked in the problem. Now, so to achieve that, so this was our earlier given one. This was R2, this was V in, this one is R1. So, this one was 99 kilo ohm, this one was 1 kilo ohm. Now, what we have done this time to improve the phase margin, the circuit has been little bit changed, and from the inverting terminal actually have connected a resistor of value R that was missing earlier. So, this is the change that we have made, to increase the phase margin. So, why the phase margin is increasing? Because by it is one of the way, though it is not a desirable way to do, but it is a very crude way of increasing the phase margin. It attenuates the gain, and so we are getting a good phase margin, or by this way we can improve the phase margin. So, this is a problem actually. So, we are solving it. So, we are not going in detail to design how a phase margin should be improved ideally, that we will not discuss. We will just tell that if some problem comes, and one of the way of improving the phase margin is just connecting the resistances in your inverting terminal, like this practice whatever we are showing now. So, how to solve that problem, or what change it will come in our basic circuit if this type of problems are given, that is our main aim to solve this one. And what we have been asked from here. So, this is the, so suppose if we want a phase margin now for this circuit, if we want a phase margin of 45 degree, what should be the new unity gain frequency. So, earlier we have calculated the unity gain frequency for the circuit when that resistance was missing. Now, we have added that resistance in view that we are trying to improve the phase margin, and then what effect it will have on the phase margin, then what will be its new unity gain frequency, that we have to find out. And the last part is the value of the new resistor. What should be the resistor value R to achieve the phase margin of 45 degree. So, these 5 problems we have to solve. So, let us start with one by one. So, first what we have to find out? We have to find out the overall loop gain. So, the circuit is for the first part, the circuit is, this is 1 kilo ohm R2, this is R1 99 kilo ohm, this is ground, this is V in. So, the overall loop gain determines, we are determining it Ls equal to minus As into beta. So, if you see in this case, in this circuit, beta is R2 by R1 plus R2, and this As actually is Gs, that is the open loop gain, and the value of Gs is 10 to the power 7 by S plus 1, 10 to the power minus 3 S plus 1. So, As equal to Gs equal to 10 to the power S by S plus 1 into 10 to the power minus 3 S plus 1. So, simply loop gain becomes 10 to the power 7 S plus 1 10 to the power minus 3 S plus 1, this is Gs minus and beta, and your beta is R2 by R1 plus R2. So, if we simplify it, R2 value is your 1, this one is 99 plus 1, so 100. So, it is coming 10 to the power 5 by S plus 1 into 10 to the power minus 3 S plus 1. So, this is our loop gain. We have to find out only the As into beta. Now, find the unity gain frequency. Now, to calculate the unity gain frequency, we will start with this relation. So, this is the loop gain. So, unity gain frequency is, so this is the solution of part B. Unity gain frequency is, we will calculate Ls, S equal to j omega we are putting. So, minus 10 to the power 5 1 plus j omega divided by 10 to the power j omega plus 1. So, we have just replaced the S by j omega, because it is a AC excitation and for a single frequency omega. we are not having any decaying amplitude in the input part. Now, mod of this value. So, mod of Ls at s equal to j omega will be 1 at frequency, that will be omega equal to omega u, that is the unity gain frequency. So, what we need to find out here? So, we have to take the magnitude of this portion. So, it is coming 10 to the power 5, we are directly squaring it. So, 1 plus omega square 1 plus 10 to the power minus 6 omega square is equal to 1. So, just we have taken the mod of this one and we have squared it up, and if you split this 1 plus omega square 1 minus 10 to the power 6 omega square into 10 to the power 5. So, from here if we calculate that omega u is going to come 10 to the power 4 rad per second. So, this is our unity gain frequency. So, what we have seen till now, that if the problem is given like that, this is any op amp problem, it is an inverting configuration or non-inverting configuration or any op amp circuit which is related with capacitance or inductors connected in its terminal, and we have to just to find out the overall loop gain, we have to find out the open loop gain which is As, which is given, and we have to determine what is the beta or what is the feedback. So, in our problem the beta we have calculated that this is R2 by R1 plus R2, and we have directly from there we have put the value and we have calculated the overall loop gain Ls. This overall loop gain is very important in the feedback stability. So, once we have got the open loop overall loop gain, we can find out that what will be the unity gain frequency from that. The C part what we have been asked to do at the above calculated unity gain frequency. So, this is our unity gain frequency, at the above calculated unity gain frequency evaluate the phase margin. So, our Ls was, we will start from the Ls 10 to the power 5 by 1 plus j omega into 1 plus 10 to the power minus 3 j omega. Now, the phase margin how we will calculate? At first we have to determine the phi of j omega. So, the angle of Ls, So, it is coming minus tan inverse of omega minus tan inverse of 10 to the power minus 3 omega at unity gain frequency point. We will put omega u minus of tan inverse 10 to the power minus 3 omega u, and putting this omega u equal to 10 to the power 4 minus of 10 inverse, this will come only 10 to the power minus 3 into 10 to the power 4. So, it will come only 10. So, if we calculate this phi of j omega, it will give you minus 174.3 degree approximately. It is in degree and our omega u we have got, that is in rad per second. So, this conversion should be noticed while calculating the value of phi j omega. Now, the phase margin is difference between the these two. 180 degree plus phi of j omega. So, it is coming minus 174.3 degree. So, it is 5.7. This is our phase margin which have been asked in the part C. So, here comes the proper introduction of the problem part D. So, we have noticed that the phase margin in the above question is going to come low, because the problem has been chosen like that. So, because of that we have introduced one more resistor. So, let us see the part D how to solve. So, this is 99 kilo ohm R1, 1 kilo ohm V in, and we have connected one more resistor which is R. Part D, what we have to find out? We want a phase margin of 45 degree. Now, what will be the unity gain frequency? Note one thing, that this unity gain frequency point only will calculate our phase margin. The phase margin will always been calculated where the unity gain frequency has been found out. So, for this one to solve, as we can see that now because of the introduction of this new resistance, the open loop gain or the closed loop gain both will have an impact. So, both will have an impact. So, now the Ls becomes, for part D, Ls becomes Gs by beta. So, ultimately what is the change? The change will be in beta, because earlier beta was R2 by R1 plus R2. Now, the beta is R2 parallel R divided by R plus R2 parallel R divided by this R1 plus R2 parallel R. Now, the new Ls becomes 10 to the power 7, that is our earlier Gs what we have considered, that is remained same, S plus 1 into 10 to the power minus 3 S plus 1 into the new beta R1 plus R2 parallel R. Now, we want the phase margin to be 45 degree. So, whatever knowledge we have of the definition of phase margin, that then 180 degree minus this part, this is our new Ls, this is our new Ls considering the connected resistance which is R, this is our new R. So, it has no impact on that phase part. So, it will be minus of tan inverse omega minus of tan inverse. So, this is required to be 45 degree what have been asked in the problem. So, from here we can write tan inverse omega plus tan inverse 10 to the power minus of 3 omega, this will be 135 degree, and then from here unity gain frequency will come 10 cube rad per second. So, after connecting this resistance, if we want 45 degree phase margin, then the unity gain frequency at which this phase margin has been calculated, that value is coming 10 cube rad per second. Now, let us have a look at the last part. or the part E. The question is what should be the resistor value R to achieve the phase margin of 45 degree, because we have seen that now the new LS is involved with some new resistance R. So, what will be the value of R to achieve the phase margin of 45 degree. So, we are achieving a phase margin which is 45 degree. We have found out the unity gain frequency. Now, they are told to find out what will be the value of R. Now, to find out the value of R, so again we will see the LS, which is, or rather we can directly take the mod Lj omega, because we know this phase margin has been calculated in the unity gain frequency point. So, that 45 degree phase margin will correspond to unity gain frequency for that omega. So, 1 plus 10 to the power minus 6 omega square R into R2 R plus R2 divided by, so this is the numerator and this total portion is in denominator, R1 plus R2 divided by R plus R2. So, at omega equal to omega u 10 cube rad per second, this part if we calculate only this part, thus this value is going to come after putting this 7071. So, 7071 into this portion, if you simplify it, it will come R2 divided by R2 plus R1 plus R1 R2, this will be equal to your 1. Now, from there we know that we have been given for this problem R1 equal to 99 kilo ohm and R2 equal to 1 kilo ohm. So, R1 equal to 99 kilo ohm, R2 equal to 1 kilo ohm. So, if we simplify this, we will see that the value of R is going to come 40.20 ohm. So, this is the value of R that we are interested in. So, this problem what we have seen, this circuit we are asked to find out what is the gain margin, what will be its phase margin, and how to calculate its from the unity gain frequency, what is the trick to find out the phase margin, and if some change comes in the resistances or if anything we employ from the outside, the how the circuit will behave in terms of its phase margin and gain margin, and especially if we want to improve that gain margin and phase margin part, where we have to connect the resistances and what impact it will have on its frequency response, that also we have seen. So, whatever problems or tutorials we have covered till now, we have seen simple circuits related to op amp, some MOSFET circuits, how we have learned how to calculate the board magnitude, we learned how to calculate or how to find out the pole frequency, zero frequency, and also how to calculate the unity gain frequency, and if we have to play something with our gain margin and phase margin, then how to do that, that also we have learned. In the next session, we will cover from the problems on some Butterworth and Chebyshev filter and some diode related problems. Thank you.